And welcome everybody to the Daily Space Weather. Once again, additional coronal mass ejection watch is in effect. We see more sunspots form, some interesting cosmology stories, and lots of views of the closest star for all you stargazers out there. Here's 171 angstroms and colorized magnetogram, and you can see this new sunspot. I believe it's 2804 is the number, and I've lost track, frankly. It's colorized magnetogram as well as ionized iron emission spectra at 171 angstroms, part of the ultraviolet light spectrum. Here's another view of the local yellow dwarf here. This is 94 angstroms. The heck happened? This is 94 angstroms. And I don't know where the full screen button went. The full screen button has vanished, folks. There it is. And you can see that flaring happening there. Some minor flares there. Nothing to really write home about. We'll show you the graph of the solar flaring a little later in the video. Here's another view of the magnetogram. This is just the magnetogram by itself, and you'll see that sunspot in the southern hemisphere forming there. The birth of a new sunspot there in magnetogram. And we'll let you know whether these are alpha or beta class sunspots at the end of the video, as that environment can suddenly change. Here's a full disk view in 304 angstroms. And we've got significant filaments in the southern hemisphere. And once again, coronal mass ejection watch in effect. I'll give it a 95% chance of a coronal mass ejection in the next 24 hours. And while it might not be directly Earth-facing, it will be in the Earth vicinity. Next, we're going to blast through a whole bunch more data here. And thanks for tuning in once again. Smash of Hazard. Here's a chart of the planets. This is where planets are now. There's where they'll be in 7 days, assuming that Nibiru doesn't show up and vacuum up half the planets in the solar system and murder you from afar. Just kidding, folks. Nibiru is not a thing. Next, looking at a star chart here. I like to use in-the-sky.org. Yeah, in-the-sky.org. And this yellow line here is the ecliptic. That's the sun. That's the path the sun will take across the sky. The 10.7 centimeter radio flux, a measurement of the radio output of the sun's corona mainly. Radio flux at 76. There's a 1-year chart from Solon.info to put it in context. And there is a geomagnetic storm forecasted by NOAA, at least. They're forecasting about a 12-hour long geomagnetic storm here, expecting a KP of 5 at the end of the day today and into early tomorrow. So it should be just subsiding when we make tomorrow's daily space weather video. We'll see. I would disagree with that, as I've forecasted the most recent Earth vicinity coronal mass ejection to be a miss. And there's lots of disagreement. Thanks everybody who viewed yesterday's video. Check out this fantastic image of Mount Etna. Shout out to Giorgio Costa for taking that crazy image of some lava fountaining and a volcanic ash plume from the now active Mount Etna. So Mount Etna did erupt again, but it abandoned the 35-hour cyclicity. So we saw 4 paroxysms over 35 hours, and then we saw it wait quite an additional period of time to about 48 hours. So the 35-hour cyclicity has been abandoned. Etna probably still erupting. And wow, and over a 10-kilometer ash plume there. Happened yesterday. Yesterday's eruption happening at about 10 p.m. local time. So that's interesting. Cyclicity change there at Etna. Sakurajima also exploding. 5,000-foot ash plume there. Mount Raung on East Java. Flight level 140. It's a 14,000-foot ash plume. Tokono exploding. 7,000-foot ash plume. Popocatépetl exploding. 19,000-foot ash plume. Fuego, the Guatemalan volcano, exploding. 15,000-foot ash plume. Sangay exploding in Ecuador. 20,000-foot ash plume. And we're unable to detect Sabancaya. It's still on the alert list. Please do not attempt to do a cartwheel or tightrope walk over the caldera. Don't fly your home-built ultralight aircraft over the caldera either. Do something more useful with your life. We don't see any major earthquakes over the past 24 hours. I'm scrolling up the list. No deep quakes at all so far. There's a deep quake in Indonesia, though, 4.9 at 136 kilometers. That happened at 12:26 Universal Time yesterday. Looks like the largest of the past 24 was this 5.8 at Indonesia. That one happened at 14:22 Universal Time yesterday, 2:22 p.m. Universal Time. Also a quake in Argentina. So another quake in Western South America, and we see lots of deep quakes there in Western South America. That 4.6 magnitude quake at 114 kilometers. And just scrolling up the list. Looks like a quake on the southern island of New Zealand there. Actually south of the South Island. That one at a 4.1 magnitude. I mean a 5.1 magnitude, rather. And let's continue on. By the way, today's Smash stream is from twitch.tv/smashomash. Thanks to our followers over at Twitch. Thanks most of all to our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com. These videos are brought to you in part by our patrons, increasing the probability that these videos will continue to exist, be free, and be publicly visible. Thanks again, patrons. The URL is patreon.com/smashomash. By the way, don't forget to visit our own website, as we saw the writing on the wall a couple of years ago, and we decided to create smashomash.org, smashomash.com. Check out our social media links, as well as links to our merch shops and our forum, which you'll find right there. Those are the links to that. And welcome to the Neo-Renaissance, folks. Today's featured product is the Google Bias shirt. Remember, folks, please don't use Google as a verb unless the verb means to use the Google search engine to obtain biased information about someone or something on the World Wide Web. And to use it in a sentence, I Googled it and now I know less about it. Now, I've got one of these shirts. Mine's red. And thanks to everybody who's purchased that product. The quality is high, and let us know if you've received it yet, if you've got it on the way, or let us know in the comments which products you've purchased. We've also stepped up our marketing. More on that later. And once again, thanks to our new viewers. If you are new here, don't forget to press like and subscribe. We'll show you one of our playlists a little bit later in the video, toward the end. We're also on BitChute. There's exclusive content there thanks to our BitChute subscribers. And hey, Smash staff, would you please re-upload yesterday's video? It's currently a YouTube exclusive. And let's do a cosmology segment. We didn't want it to be a YouTube exclusive, but it didn't process for some reason on BitChute. We'll have to re-upload that. Let's do a cosmology segment real quick. Big data is mapping the cosmic web. So there on the left, you can see one of the maps of the cosmic web. This is the galactic scale, folks. So we're talking about cosmology in its purest form here. And you can see the filamentary-like structure of that. It all has to do with poloidal fields. I won't get into it, but this article is on phys.org in the Astronomy and Space section. Big data to model the evolution of the cosmic web. So that's interesting. It requires a lot of computing power to do so. Again, it's on phys.org in the Astronomy and Space section. And before we look at a random object today, we're going to take just a quick moment to look at Sagittarius A star. So what's going on with Sagittarius A star? Well, it's the core of the Milky Way galaxy. So if you want to look at this on Aladdin Light, Sagittarius space A asterisk. That's Sagittarius A star. I just wanted to bring to the attention of our viewers the Finkbeiner spectrum. So this is the hydrogen alpha composite survey. And so what we were just looking at there is the UMass. That is infrared light. However, we know that there's lots of, let's just say there's lots of hydrogen floating around out there in space. And a lot of it's flying around at extremely high speeds. And so the hydrogen alpha spectrum is super important in terms of the underlying structure of things like the Milky Way galaxy, indeed all galaxies, and the cosmic web. So if you pick your favorite object, I just picked the core of the Milky Way galaxy here because the Finkbeiner survey is mainly the Milky Way galaxy. It also includes the Large Magellanic Cloud and so on. But note the structure of hydrogen. So this is very interesting because these filamentary structures give us lots of insight. Now I'm moving off of Sagittarius A star here, but you can see various filamentary structures here detected by the Finkbeiner survey. It's quite spectacular. And this is the emission spectra of hydrogen. There are a lot of structures out there. What is up with those structures? It's part of the reason why we study cosmology. Now let's pick a random object. And we're going to look it up at the Neil Gorel Swift Bat X-ray Observatory, as we do most days. And if you're not familiar with the Neil Gorel Swift Bat X-ray Observatory, it's a constant X-ray monitor of over 1,000 objects. So we'll pick a random one right here. Between 1 and 1031, today's quantum random number picked number 78. And by the way, thanks to Mr. Keebler for verifying whether or not we viewed yesterday's object before. Today's object is Galaxy 3C66A, a BL Lacertae object, another active galactic nucleus. And this one will have a full spectrum of photonic emissions, let's just say. So here are the X-rays from that object 3C66A. And we'll show you a quick view of this on, here it is on Simbad. We'll bring it up on Aladdin Light and look at it in a few different wavelengths here. Here it is in infrared light. And it looks like a sphere because you're looking perpendicular to the ecliptic plane of this galaxy. You're looking down the pole. That's got to do with why you're seeing such a full spectrum of emissions from it. Not showing up on the Chandra. There it is on the XMM Newton, the multi-mirror project. It's Galaxy 3C66A, a BL Lacertae active galactic nucleus. And let's talk cosmic rays real quick. We'll also talk about smashamash.com/forum. Another galactic source of gamma rays. So this particular source, known as HAWC J1825-134, one of the most powerful likely cosmic ray sources ever known. We're talking about gamma ray sources emitting energies in the tera electron volts. And less than a dozen sources emit more than 100 tera electron volts. This one, there's an even bigger number there. And once you get into numbers that are that big, it becomes incomprehensible. I'm not going to try to recall what that was. It's another phys.org article in the Astronomy and Space section. And this was enough to get us to, oh, this one is in the peta-electron volt range. Another magnitude of energy higher than tera-electron volts, which I guess is in the quadrillions of volts. I don't really know. But in any case, we've updated smashomash.com/forum to include this object. So if you head to smashomash.com, you can find a link to this, our forum, and one of the forums there is a cosmology forum. And this one has, one of the topics here is the most, and feel free to update this with your the most object that you're interested in when it comes to cosmology. For instance, we started it out with the most powerful radio source, second only to the sun, massive radio galaxy Cygnus A. And all of our daily space weather viewers are, of course, invited to check out smashomash.com/forum. It is free so far, and that's today's cosmology segment. Let's move on. So here are those X-ray flares we saw, a series of B-class flares, like about 6 or 7 of them there happening in the past 24 hours. And they came out of both of those relatively new sunspots. One is about 2 days old and one is about 1 day old. Here's the proton flux. We don't see any proton strikes here. No coronal mass ejections have struck at the level of the GOES 16 yet, which is making its measurements in the ionosphere, by the way, folks. And there's the graph for the X-ray flux. And there's the graph for the proton flux. X-rays. And these are solar flares, folks. Don't get them confused. Solar flares are X-rays. Coronal mass ejections are mainly hydrogen nuclei, otherwise known as protons. There's also some helium and some other elements, some molecular elements, and some electrons in there. Next, looking at the real-time solar wind here to see the solar wind density at about 7.2 protons per cubic centimeter. Solar wind speed still significantly elevated as the coronal hole wind stream goes on and on for days. Current solar wind speed around 580 kilometers per second. And we briefly went back into geomagnetic unrest early in the morning today, universal time. And there you can see that's KP4. We had nearly 24 hours of a KP4 there on the 21st. It's all from that coronal hole wind stream. So here's the Magneto hydrodynamic pressure. You're looking at the Geospace Magnetosphere movie. It's 4 hours of data. We show it daily. It's a great time to take a sip of your coffee. Or if you're drinking something else, let us know in the comments what it is. And you see that elevated pressure there as the coronal hole wind stream continues, and it's creating some ground magnetic perturbations. Here are the ground magnetic perturbations closer to home on planet Earth at the poles. Some major perturbations there over the North Pole, especially the Siberian side. So southern Greenland, places like that, Iceland, should have some great aurora imagery coming out in the next day or so. We should see lots and lots of auroral imagery. There you can see some perturbation. This is the global view, the flattened synoptic map here. And yeah, significant magnetic perturbations continue on the surface of the planet, a result of that incoming solar wind. So here is the auroral forecast. And this will calm back down at the end. We'll see where the most recent aurorae are likely to be, and it's probably lined up with where you see those ground magnetic perturbations. And if you're viewing from one of these northerly regions or from Antarctica, and you've got images of the aurorae, let us know. Drop us a line. You can find ways to contact us at smAsho.com. Next, looking at the magnetic data, and we see some surprisingly high spikes here at midnight time. These N's and M's, that's noon, and that's midnight local time for the GOES 16. How strong is the south solar polar field? Pretty strong. In any case, here's the top view ecliptic plane field plot showing us the polarity of the current sheet. Earth still solidly in the south pole current sheet. Keep in mind the magnetic environment can suddenly change, and that this data is 1 hour and 36 minutes old already by the time we made the video. Expect to see some more high readings from the GOES magnetometer. And future performance of this will be based on the evolution of those two new sunspot groups, which I believe are both beta class, but we'll let you know by the end of the video. Here's a line of sight plot. It shows you the solar magnetogram and the poloidal fields there. The poloidal fields, the fields which emanate from the solar poles. And you can see a little bit of change here in the B field being pulled up and then back down. Next, we'll look at the coronal hole line of sight plot. And the coronal hole that's been supplying us with a plethora of protons is this one right here. That one right there by my arrow. Also another South Pole oriented coronal hole moving into the Earth-facing zone now at a similar latitude to the last one. And here's a magnetic field plot of the solar corona. The sun's atmosphere, a chaotic place. We show it daily. And if you want to know what was going on a previous day, you can view one of our previous videos. Here's a diagram of the atmosphere. And let me just check the life of the stream here. Again, we are streaming live at twitch.tv/smAshomash. So yeah, here's a diagram of the atmosphere. If you have to pause this, feel free. We include this to show you where the GOES 16 is making its measurements, around 300 kilometers at the F ionosphere layer. Here's a diagram of the Van Allen belts and the altitudes of some more spacecraft, such as the low Earth orbit of the International Space Station, which is about where you would be if you went into space most likely. And we see significant charging hazards here, especially over the southern Indian Ocean and western Pacific. Don't be surprised to see some data loss from satellites and so on as a result of this. A CCD bakeout is when a satellite shuts down its charge couple device in order to prevent damage. So our technology is pretty good at doing this, and there's a lot of forecasting that goes into it. It's part of the reason we have a channel. Now, we saw the electron flux make it all the way up to nearly 10 times alert levels here. This is a magnitudinal scale here, as you can see, 10 to the third, 10 to the fourth, 10 to the fifth. We saw over 9,000 pulse flux units. It's not the strongest electron storm that we've ever reported on the channel, but it's pretty strong. 10 times the alert level there. Just about 10 times the alert level there. And patrons, don't worry, the alerts will be back soon. I had to get a new device because my device got a little bit smashed. Maybe we'll make a video about how smashed that device got at a later time. Perhaps a negative product review. So here's the 1-year chart of the electron flux to put that in context. You can see quite high levels here over the past 24 to 36 hours. And here's a visualization of it. This will give you an idea where GPS errors will occur. And typically we see the most GPS errors and the most significant ones happening around the equator at noon. This is the total electron content, a visualization of the entire atmosphere all the way from your handset to your GPS satellite. And not surprising, it lines up with where we see charging hazards for satellites. Here's the forecast. NOAA forecasting a little bit higher levels. I have no argument there, as the current coronal hole wind stream is lasting inordinately long, and it's quite surprising. So in any case, there's the electron content. The relativistic electron forecast model. The green boxes are the forecast, and the yellow diamonds are the observation. Here's the ionospheric visualization. Ionosphere looking pretty normal right now. Nothing too exciting to report on there. Here is the latest image at 9:30 Universal Time. Small area reaching 14 megahertz there at eastern India. It's the Bay of Bengal, I think. Now, we're moving into meteorology subjects. And I've got something to say about this. Oh my God. Look at the jet stream in the southern hemisphere, as well as the northern hemisphere. We've got it blowing backwards here near the pole, in the north geographic pole area. And then we've got these extreme meridional jet stream bends. Look at this. 2 180-degree bends in about 1,000 miles there over the extreme southern Indian Ocean off the west coast of Australia. Extreme jet stream flow, and the jet stream blowing backwards over parts of the Indian Ocean and the West Pacific once again. We cited this yesterday as well. Here are the jet streams of the Western world. A little more coherent, although some extreme bends there over the Central Pacific Ocean as well. And some hot air being injected down toward Antarctica here in southern hemispheric summer. Check out that massive cyclonic system there. Wait, no, my mistake. That's an anticyclone, folks. And it does translate all the way to surface winds. We've got this stagnant air here off the southwestern coast of South America. And there you can see that anticyclone at the 250 hectopascal winds. Anticyclones rotate counterclockwise in the southern hemisphere. Let's talk more meteorology. Lightning. I like to use lightningmaps.org when I hear thunder, especially. But also checking out the global real-time lightning map. And we've really seen a lull in lightning here over the past 3 or 4 days. Quite low levels of lightning here. Next, looking at pressure cells on windy.com. There's where pressure cells are now. We'll advance this into the GFS forecast for tomorrow. There's where things are expected to be at 12 noon tomorrow Eastern Time. Low pressure dominating the South Geographic Pole region. So you see all of this low pressure down here. South Pole pretty much entirely encased in low pressure. Moving on. Trying to move on. Here's what's going on in the cloud layer. Low clouds still over much of the Atlantic Ocean there. Low clouds clearing up a little bit here over the Gulf of Mexico. Here's a water vapor map. We'll show you the Doppler radar next. Again, there's the cloud situation. There's the water vapor situation. Dry air over pretty much the entire lower portion of the 48 states. And you can expect clear skies when you see a place like this. That is high pressure associated with that dry, massive air. Yes, folks, it's true. Dry air is more massive than moist air. Next, looking at U.S. Doppler radar map. Some snow continues to fall. And let's just check the global cryosphere watch site. If I can type. As I'm interested in the snow mass balance and the snow extent And check out the snow extent. So it looks like a lot of the snow in northern Europe has actually melted there, as well as some pockets in the U.S. Snow extent now more into a normal range, just moving back into the 1 standard deviation range. So that's snow extent, meaning the two-dimensional account of how much coverage of snow we have on the northern hemisphere. And here is the snow mass balance. Once again, well outside of the 1 standard deviation range, not quite as far outside as the past 3 winters, but still quite snowy. Apparently the planet is so hot that it's cold, which is, by the way, a real argument for global warming alarmists who would prefer you to believe that carbon dioxide controls the climate. Hey Smash team, thanks for tuning in. Stay tuned, we got bonus features. Before we do that, please press like and subscribe on YouTube. Share with your friends and foes. Thanks to our new viewers. If you are new here, again, press subscribe. Press the notification bell. We'll be keeping you posted about the likely oncoming coronal mass ejection. There is a 95% chance of an additional coronal mass ejection. And I would also note our playlists. So here's one of our playlists. Nature, get outside, people. You can find all of our playlists at youtube.com/smashamash/playlists. And here is a tidbit. Actually, let me check the life of the stream first real quick and allow me to vanish. Here's a tidbit from one of our nature videos. If you're sick of winter, maybe play this one on the big screen and get immersed in a video from last year.
Blue Jays.
Yes, a nice green, sunny, warm forest with blue jays, folks. It'll make you feel good, 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 good. Yes, I filmed my shadow intentionally. And we've got some additional views of the sun here. We're going to show you the most current high-res colorized magnetogram, as well as the most current high-res views of these new sunspots. So there's the full disk view. There's the new sunspot. That is certainly beta class. Likelihood of solar flares has gone up significantly with that. And the more these move out of the Earth-facing zone, the more likely we'll see more intense solar flares. Here's the other sunspot, also beta class, so significant possibility of solar flares, folks. There you can see the opposite polarities of the newest sunspot. I think it's 2805, and I think this is 2804. Pretty significant sunspots. And let's get to our last sets of imagery here. We ended things with the 304 angstroms. Let's move into the 193 angstroms realm. There's 193 angstroms, another UV emission spectral state of ionized iron. Coronal hole rotating in on the southeast. And you'll be able to see the flaring of those 2 new sunspots. 3 active regions on the Earth-facing zone, the sun looking a bit like a bowling ball. Here's sunspot 2804 in 304 angstroms. Great view of that. Here's sunspot 2805. If I've said the wrong numbers, just correct me in the comments. As the physics is more important than the numbers of things. To quote Einstein, never memorize something that you can look up. So there's a great view of that new sunspot, as well as some filamentary activity. Here's 171 angstroms. Fantastic view of the new sunspot. And here's the northern hemisphere once again. And it's about time to close things out. In any case, thanks for tuning in, folks. Remember to stare at the sun. Attempt to understand the physics. When you're staring at the sun, don't drink, but if you do, don't drive. Seriously, don't drive. No matter how much I like you, I don't want to see you on the roads. I like uncongested roads. I'm a professional. And also, welcome to the Neo-Renaissance, and may that solar wind be at your back.